Chapter 7.4 Parallel Lines of Proportional Parts. If a line is parallel to one side of the triangle, so in this diagram, line BE is parallel to side CD, then it intersects the two sides and divides the sides into segments of proportional length. So in this picture, it would divide AB and BC. So AB over BC would equal AE over ED. In the first problem, we are told that VU is parallel to RT, so we set up our proportions to solve the problem. So X over 12 would equal 3 over 8. We would cross multiply to solve for X. And we have X equals 4.5. In this problem, we're told that XY is parallel to side AC. Again, setting up a proportion to solve the problem, we would have X over 6 would equal 10.5 over 4. Cross multiply. And solve for X. We have that X is equal to 15.75. The converse goes the other way. If we can show that AE over EB equals CD over DB, then we can say that AC and ED are parallel. In the next problem, we don't know that GH and FE are parallel. We want to prove that they are or they're not. So we're given that DH equals 18, HE equals 36, and DG is 1/2 of GF. So if I let DG be X and GF be 2X, then DG is half of GF. So I want to check, is 18 over 36, is that equal to X over 2X? Simplifying these, 18 over 36 simplifies to 1 over 2. X over 2X is equal to 1 over 2. So yes, because the sides are in proportion. In the next problem, we have that XY is 15, YZ is 25, WA is 18, and AZ is 32. So we want to know, is 18 over 32, is that equal to 15 over 25? Reducing 18 over 32 becomes 9 over 16. 15 over 25 can reduce to 3 over 5. And those are not equal, so the answer would be no, the sides are not in proportion. The midsegment of a triangle is a line that goes from the midpoint of two sides of the triangle, and that line turns out to be parallel with the side that's opposite it, and it's 1/2, so JK is 1/2 the length of FG. So for problem A, DE and EF are midsegments of the triangle ABC, and we want to find AB. So we want to find AB. And we know that AB and ED, or DE, since DE is a midsegment, it is half the length of AB. So ED equals 1/2 the length of AB. Well, ED is 5, so AB would have to be 10. In the next problem, we want to find FE. We want to find this length here. Well, it's a midsegment. This length here is 18, so FE is half of BC, so FE would be 9. In the next problem, we're told that DE and EF are midsegments of triangle ABC. We want to find the measure of angle AFE. So AFE, we want to find the measure of this angle. We know that FE and BD are parallel to each other. And we also know from this midsegment here that these two are parallel to each other. Well, FE would be the transversal, which would make this angle and this angle alternate interior angles. So angle FAE would be 87 degrees, and that's because parallel lines give you that alternate interior angles are congruent. In the next problem, we want to find the length of BC. So we want to find this length here. This length is a midsegment. BC is twice the amount of DF, so BC would be 16. In the next problem, we want to find the length of DE. DE is a midsegment and is parallel to AC. DE is half of 15, which would be 7.5. In this problem, we want to find the measure of AFD. Well, we know that DE is a midsegment. So DE and AC are parallel. These two angles here are alternate interior angles, so it would be 122. If 3 or more parallel lines intersect in 2 transversals, they cut off the transversals proportionally. So in this picture, we have that AE is parallel to BF, is parallel to CG. So we know that AB over BC is equal to EF over FG. In the figure, Large, Maple, and Nuthatch streets are all parallel. So these 3 streets are parallel. The figure shows the distances between the city blocks, and we want to find x. So x over 16 would equal 26 over 13. We can cross multiply and solve for x. So x would equal 32. And the figure Davis Broad and Main Street are all parallel. We want to find x. Setting up our proportion, we would have 24 over 8 would equal 15 over x. Cross multiply to solve for x. And we would have that x equals 5. If 3 or more parallel lines, so here we would have that AE is parallel to BF is parallel to CG, and they cut off congruent segments on one transversal, then on every transversal they'll cut off congruent segments. Not that all 4 are congruent to each other. It would be that AB is congruent to BC and that EF is congruent to FG. In this problem, we want to find x and y. We have these 3 lines are parallel to each other and they cut off congruent segments in one transversal, which tells us that the other transversal where they cut that off is also congruent. So we know that 3x minus 7 equals x plus 5, and we're going to solve for x. And we have x equals 6. Solving for y, we have that 9y minus 2 equals 6y plus 4. And y equals 2. We want to find a and b. We're told that these 3 lines are parallel to each other and that one transversal is cut into 2 congruent segments, which means the other one is also cut into 2 congruent segments. Setting up for a, we have 4a minus 5 equals 3a plus 6. So a equals 11. Solving for b, we have 3b equals 1/3 b plus 2. Excuse me, that's 5/3 b plus 2. We'll multiply both sides by 3. And solve for b. So b equals 3 over 2. And that concludes our lesson for 7-4.